part 2. We're going to do 11 through 20 here on this 2018 practice test. So how about this? That looks like integration by parts. Looks like tic-tac-toe, right? So x and cosine of 2x. So here I take my derivatives. I don't know why I put that line there. That was annoying to do. And then antiderivative of cosine is positive sine of 2x. And since there's a 2 in there, I got to put a 1/2 here. And then the antiderivative of sine is negative cosine of 2x. And another 2 comes out dividing like. And then there's my 2. So I have 1/2 x sine 2x, so these are the two that have the right first term, and then plus. So it comes down to getting the signs right. I guess you got to get the first term right. But, there you go. 11 is D. Number 12, given that 3x minus tangent y equals 4, what's dy dx in terms of y? Okay, let's see what we can do. I'm going to take the derivative just straight through of this. So derivative of 3x is 3. Derivative of tangent y is minus, minus tangent y is minus secant squared y dy dx. This is implicit differentiation, going back to unit, or chapter 4.1, I think. So it'd be 3 over secant squared y, which is the same as 3 cosine squared y. Which of the following graphs is a logistic differential equation? I know what logistic differential equations look like. They look like this. It's D. Oh, that was cool. Now, you could, what if there were more of them? Like, do we know more than that? Well, sure. You could have like a logistic decay equation that did look like this, but that would have to be negative here on the outside. And the carrying capacity of this, it's whatever makes this equal to 0. So let's see, 1 minus, so that would have to be 500 there. There's your carrying capacity. But boy, that's, don't take more time than you need to here. What's the absolute minimum value of y equals that on this closed interval? We would need to find the derivative and set that equal to 0. So sine x minus cosine x, that's when they're equal to each other. That's going to happen at the square root of 2 over 2. But we also have to check the endpoints. Right? Sorry, that's what it's equal to, at pi over 4, and then pi over 2. So what is our function equal to at these three values? At 0, it would be negative 1, and at pi over 4, it would be minus square root of 2 over 2 minus the square root of 2 over 2. That would be minus the square root of 2. And then at pi over 2, it would be, that's 0, that would be minus 1 again. So it looks like that is the minimum value there, which is C. So 14 is C. 15, graph of g prime, first derivative of the function g consists of a semicircle and 2 line segments. This just reeks of find the area, doesn't it? If g of 0 equals 1, what's g of 3? Well, fundamental theorem says that the integral of g prime of x dx from wherever to wherever is equal to g. All right, that's fundamental theorem. So the area from 0 to 3, that's a quarter circle. The whole circle of radius 2 has an area of 4 pi, so this has an area of pi. And then this triangle is 1 wide and 2 high, so that has an area of 1. So this is pi plus 1 is equal to g of 3 is what we're looking for, and g of 0 is 1. So pi plus 2. looks like is the correct answer. And we'll do the next 5 in the next video.